Hello students, welcome to DEY'S Learning. In this video, we are going to solve one MCQ problem from JEE Advanced paper 2021. But before that, if you don't subscribe my channel yet, do it now. Let's get started. So you can see the question on the screen. The question is the reaction sequences that would lead to orthoxylene as the major product is or are. That is, the question is more than one characteristic type, right? So we have to check the options one by one, right? So firstly, obviously we have to know the structure of orthoxylene. The structure of orthoxylene is this one, benzene ring. If the benzene ring contains two CH3 groups at the ortho positions, the compound is known as orthoxylene, right? So this is our molecule which is orthoxylene. So we have to find the option where orthoxylene is a product of a sequence of reactions, right? So let's check one by one. In option A, this molecule has been given. The molecule is CH3 and NH2 at the ortho position, right? Okay. Now this molecule is treated with sodium nitrite NaNO2 and dilute acid, right? At 273 Kelvin, that is 0 degrees centigrade. Do you know the name of the reaction? It is diazotization. Okay. So on diazotization reaction, this molecule has been converted into N2 plus and Cl minus. Right? This is diazotization. This NH2 group is converted into diazonium salt. Right? Where Cl minus is the counter ion. The name of the reaction is of course diazotization, right? This is diazotization. Diazotization, right? Now, in the second step, this molecule is treated with cuprous cyanide, right? That is CuCN. Okay. Cuprous cyanide, right? Now, what will happen? The name of the reaction is Sandmeyer reaction, because in Sandmeyer reaction, this diazonium salt in presence of cuprous cation is converted into the cyano or halobenzene, right? So the product of this reaction is this CH3 will remain intact and this diazonium will be converted into C triple bonded. This is the cyanide ion, right? So the name of the reaction is Sandmeyer reaction. Sandmeyer. This is Sandmeyer reaction, right? Now, in the next step, this compound is treated with divalent. Do you know the function of this reagent? Divalent. This is diisobutyl aluminum hydride, right? And then hydrolysis has been carried out. Okay. So divalent actually reduces this cyanide group into CHO, that is aldehyde group, right? So it is actually the modification of the Stefan's reduction, right? In Stefan's reduction, cyanide group is converted into aldehyde group. So this is actually the modification. Look, this one CH double bond. This is actually the modification of Stefan's reduction. In Stefan's reduction, this cyanide group is converted into CHO, and of course, in presence of divalent also, this cyanide group is reduced by this hydrogen diisobutyl aluminum hydride. this hydride ion will reduce this carbon to form CHO. Firstly, imine will be formed, and then hydrolysis. Firstly, imine will be formed, and on hydrolysis, this imine will be converted into CHO, right? And in the last step, this reagent has been given. The reagent is N2H4. The name of the molecule is hydrazine. Hydrazine in place of potassium hydroxide, and heat will be given, right? So the name of the reaction is Wolff-Kishner reaction, and what will happen? This CHO group will be reduced to alkane, right? That is CH3. So our end product will be CH3, and of course this one is also CH3, that is orthoxylene, right? So the name of the reaction is Wolff-Kishner reduction. This one is Wolff-Kishner reduction. Wolff-Kishner reduction, where carbonyl group is reduced to an alkane, right? So in option A, the given sequence of reactions produces actually orthoxylene. So of course, option A is the correct answer, right? Now let's check the other options. Now let's explain the reaction sequences given in option B, right? So the starting material given in option B is this one. This one is methyl, and this one is bromine, right? Now this molecule is treated with firstly magnesium, then carbon dioxide, and then H2O plus, right? Now actually there are two steps are involved there, so we can write it one by one. So let's explain the first step, right? Now in presence of magnesium, of course in presence of dry ether, which is not given, the solvent is dry ether, Grignard reagent will be formed, right? So this one is methyl, and this one will be MgBr. This is actually an insertion reaction, right? So the Grignard reagent is formed. Now in the next step, this Grignard reagent will react with carbon dioxide, right? CO2. So what is the reaction mechanism? This is your CO2, right? And this carbon is del positive, oxygen is del negative. So actually this portion of the molecule, will attack at the positively charged carbon center, and this pi bond will open up, right? So this carbon will get attached to this one, right? And this will be C+O minus, and in presence of HCO plus, that is acidic workup, you will get this molecule, one carboxyl group, methyl, and this one will be carboxylic acid, right? C+O minus, and then on acidic workup, this oxygen minus will take up one H plus from the medium to get converted into COOH, right? Now this molecule will be treated with SOCl2, right? That is thionyl chloride, SOCl2, and SOCl2 will convert this COOH into COCl. That is, this OH group will be converted into Cl, right? So the product will be this one is methyl, this one is CO and Cl, right? Now the given reagent is hydrogen palladium barium sulfate. Hydrogen and then palladium and barium sulfate. Do you know the function of this reagent? This is Rosenbaum reduction, right? So on Rosenbaum reaction, this COCl group will be converted into CHO. That is, this bond will be broken and this hydrogen will be attached at this carbon and with Cl. So you will get CHO, right? So your product will be this one is methyl and this one will be CHO, right? CHO, right? And in the last step, the reagent, so this is actually Rosenbaum reduction. You can write here, this is Rosenbaum reduction. This is Rosenbaum. This is Rosenbaum reduction. Right. Now, in the last step, the reagent given is zinc amalgam and concentrated HCl. Zinc amalgam and HCl. The name of the reaction is Clemmensen reaction. Okay. So on Clemmensen reaction, of course, this CHO, this aldehyde group will be converted into another CH3, that is methyl group, right? So this is, so the end product is again orthoxylene, right? This one is orthoxylene, and of course this one is known as Clemmensen reduction. The function of Clemmensen reduction and Wolff-Kishner reduction are same, but Clemmensen reduction is performed in acidic medium, and the previous one that we have learned in option A, Wolff-Kishner reduction, which is carried out in presence of base, right? So this is Clemmensen reduction. This is Clemmensen reduction. This is Clemmensen reduction, right? So our end product is again orthoxylene. So of course B is again the correct option, right? So both A and B are the correct options. Now let's check option number C. In option C, this molecule has been given. This is our substrate molecule. This one is methyl and this one is a vinyl group, right? Now this molecule is treated with a BH3. This is diboron. This is boron hydride, and of course in presence of H2O2 and sodium hydroxide. This is actually a two-step process. This is hydroboration and this one is oxidation, right? So the reaction is hydroboration oxidation. And what will happen in hydroboration oxidation reaction? The OH group will be attached at the less substituted carbon, right? This one. That is, OH group will be attached at the less substituted carbon. Okay, so this is actually hydroboration oxidation reaction. This is hydroboration, then oxidation. This is hydroboration oxidation reaction, right? Now this molecule is treated with PBr3, right? Now this molecule is treated with PBr3, that is red phosphorus and bromine, right? And in presence of red phosphorus and bromine, that is PBr3, this methyl group will remain intact and this bromine will substitute this OH group, right? So you will get this one is bromine. And finally this molecule is treated with zinc and HCl. zinc and HCl, what will happen? Zinc HCl will reduce this haloalkane into alkane. That is, you will get that bromine will leave the substrate, bromide will leave the substrate, and that will be replaced by hydrogen, right? So it is our end product, but obviously it is not orthoxylene, right? Orthoxylene contains two methyl group. Orthoxylene contains two methyl groups at the ortho position, but this molecule contains one ethyl and one methyl group. So it is not our correct option, right? Now let's check option number D. The substrate given in option number D is this one. This one is benzene ring and this one is a fused 5-ml ring, right? Now in the first step, ozonolysis has been carried out. So our reagent is O3 in presence of zinc and water. That is reductive ozonolysis, and on reductive ozonolysis we know this double bond will be broken and one oxygen will be attached by double bond and another oxygen will be attached by double bond. Okay, so our product will be, after ozonolysis, our product will be C double bond O, and this one is this one, and this one is of course C double bond O. I can write here, right? This one is this carbon, and this one is that carbon, and this one is this carbon, right? Okay. 1, 2, 3, 4, 5. That is 5-membered ring. No problem. Now this molecule is treated with N2H4, that is hydrazine in presence of potassium hydroxide and heat, KOH and heat, and of course this is known as again Wolff-Kishner reduction, and this oxygen will be reduced and this carbon oxygen bond will be reduced, and again this carbon oxygen bond will be reduced. During Wolff-Kishner reduction, the carbonyl groups will be converted into alkane, right? So our product will be, this one is CH3, right? And this one is CH2, then CH3. So of course, okay, this one. So of course, this one is not orthoxylene again. And the reaction is Wolff-Kishner again. The last step is Wolff-Kishner. reduction. Wolff-Kishner reduction. Right. So option D is not our correct option, right? So the two options which are correct. So the two options which are correct for this question is option number A and B. Okay. So in this video we solved one MCQ question from JEE Advanced Paper 2021. So we will meet in the next video. Bye bye for now.